watching this video. So today I will explain a bit how to work with annotations processor. So annotations processor essentially the way we can reduce our amount of code, I mean the bird code, so to move the code generation itself. So instead we writing amount of code is very verbose and it's very boilerplate, so we can remove that completely from our on manual process, from the manual process to code generations. So here I'm creating three modules which is consists about like examples and also annotations and a processor here. So example essentially our entry point, like the main class itself. So this is just our entry point to running the app. So annotation here is very obvious. So this is where we like putting our annotations classes. And then the last but not least is the processor itself. This is the core business logic, how we can like creating our code generations by using kotlinpoet, which helped by the auto services from the Google. So in summary, the root build.kernel is very normal setup, so there's nothing magic here, just like adding the Kotlin Gradle plugin and also have the plugin there. And the processor itself only contains about the Kotlin point, which is we can use for creating annotations processor, the auto services, and also the KPT for auto services. So here in the processor we're using the KPT for Kotlin annotations processor. Why we using a KPT from the auto services here, or why we should implement the auto services here? Because this can help us to reduce amount of manual process, which is we used to uh, doing that, or when we create annotations processor, which we intend to like creating the resource file here. So for instance, we are not using auto services here. So in order to like the entry point of our processor can be like available during compilations, we need to like inform the compiler to pick that, right? So to pick that, if we are not using autoservice, we should like mention here somewhere on the resource file here. So resources here. So like a meta information and put our the packet class of the processor itself, so the compiler can pick that and running the process automatically. But by using auto services, we no need to creating the resources, which is we can just adding auto service annotations and put as processor, then the compiler will be automatically pick your processor and running that automatically. So it's very big deal, right? Cool. So now we can like creating our processor here. So in today's presentations, I want to like have creating annotations processor which can help us or me essentially to creating or providing annotations of value or constant value. So for instance, in my case, I want to like creating a function like do work here, for instance, for simplicity, and then I can just like creating a constant annotation which is has a prop name and a prop value, and then I want to like from this code generation, from these results, I want to like calling this on and print something like do work prop value, for instance, or prop name, something like that. So I went to doing that. So this is our end goal here for today discussions. Cool. Nice. So in order to doing that, so now we can create our constant processor, which implement abstract processor here, and we're adding other service and putting a processor. Cool. Now we implement the process, not just splitting it into two. The second is about the version itself, the support version, source versions, data support. So which versions that you will be supporting for this library? Okay, cool. The second thing is about annotation itself, the type. So now we are going to creating our annotations here. Constant. So annotation class constant. We have a prop name, and we have a prop value string, and our target is only for a functions. I don't care with the other target. And retention is only source because I want to skip it on the source. Cool. Yeah, so far so good. I think we are done on the annotations. So now we are going to add some support. I think should import this. Okay, nice. Coach class dot java dot name. Okay, this is our brain here. Because the annotations and run environment can be null, so it's safe to adding some check here. Sorry, if the run environment is null, then returning false run process. But I want to adding some process environment um log, because we cannot using conventional println, so we cannot add that. I mean, we can add that, but println will be not like printing on the log, so we need to like using built-in log from the process environment, which is the messenger. The print message I think should be, the first one is diagnostic.kind.node, the message itself. Nice. So I think the second thing is creating for the error message. Nice. Okay, cool. So what I can do is that passing environment, not message closure, and mentions about is no, and skip the process. Second thing is guard for annotations. I think we can do something like that. It's no, or somebody. That remains is no, or empty, and skip the process. Cool. So far so good. This is our guard. Now I want to check if the elements or round environment is contains our constant here, because I just care about our constant here. So, and by the way, the process here can happening. I mean, the process can happen in multiple time, because the way annotation processor work is that they having like multiple round. So for instance, we have some sorts classes, and some have some annotations like maybe builder annotations or digger annotations, whatever. So it may be like happening on the first round. So maybe like our constant is not happening yet, and then the second round, and then our concern is the process of our concern is happening on the second round. So makes sense that if we can like guarding the round environment based on our concern, based on our something that we care about. So in order to doing that, so let's declare some elements here, elements, and round environments, get elements, the constant, and class itself. Cool. So we should check if this element is empty, so we return a false, right? Skip. So processing information, not message. I think not able to find constant in run information. Cool. Nice. So we are fine. So assume every functions that happening here in our downstream. So it's already have our constants, right? Now we can safe to say that we can loop through the elements. In elements, we can create collections annotated, annotate element get element get annotate constant classifier. Cool. Now we can add the prop name, which is annotate prop name, prop value, annotate prop value. So now we can creating our property. So in order to creating a property on a code generation, so we can use kotlinpoet. So we can okay. Oh, sorry. Before that, we should create our package name here. The package name like com.example maybe. File name is just like a constant generated maybe. And now I'm creating a object, a single object. Creating a create object builder, object builder like tab spec object builder. It's a file name, prop builder, property, prop spec builder. Name is the property name. Type is a class name. A type is essentially kind of like import. So because we using strings, right? So we need to declare import as Kotlin string also. So essentially on the code generation, it will be like manifesting something like import Kotlin dot string, something like this one on the code generations. And then the third argument is declaring the modifier. So we have using key modifier is the constants, and key modifier is a final. And then should be not able to mutate this one. The initializer is our prop value. Cool. Now we add object builder into the prop builder. So prop builder, I don't know. So object builder, add property, prop builder, sorry, prop builder dot build. So it's good. Now we creating a file, like create file. So we can use a file spike. What I'm doing, the builder package name is a package name, file name, and the app type, the object type itself, the build. Now we can can write to file on the code generation source. I think I should have something like generated source, something like that. Process increments option. Then we should have like something like companion maybe. Console KPD Kotlin generated KPD Kotlin generated. Cool. No, it's not the one. So here run. What happened here is that returning a false process increment error message can find target source, something like that. Maybe generate source file here. I think so far so good. Let's go back on our entry point main class here. A constant prop name hello word to work. Let's running this. Okay, cool. So let's see how it looks like. Okay, should be manifest on sample generate kbd. Nice. So here we go. So yeah, we're able to like, let's see, we can like maybe like code generate hello. Nice. So we're able to like running this example, I mean pick from the code generations and print one. So far so good. Cool. That's from me for today presentation. It's very brief about annotations processor. So it's like you see that it's very straightforward, right? So we're creating our object builder. We find our annotations constant. We create our property spec, and then we creating a file. So and write into the expected source. So we are good. So yeah, that is something that's very brief explanations about an example about code generations and regarding annotations processor. If you have any like questions or feedback on this video, please feel free to like comment on below. Let me know. I will really appreciate on that feedbacks. Okay, I think we are done on today's presentation. So see you. Bye bye.